So hi everyone, my name is Austin McGee. I'm the Chief Product Officer and co-founder of Arch. And at Arch, we're trying to make it as easy to build a new connected device product as it is to deploy an app on IBM software, for instance. This was me 2 years ago. The man next to me, his name is Thomas. He's an entrepreneur living in Ifakara, Tanzania. And he's responsible for making sure that dozens of these hand pump wells are continuing to function every day. And it's a difficult challenge because it takes him a long time to go and travel to each of these remote locations and check on the functionality of those pumps. So this was a big moment for us 2 years ago because we actually built, for my previous organization, Well Done, which is a nonprofit, we were building a connected device that's visible at the bottom of the screen there, which monitors how much water is flowing and reports to Thomas every day so that he knows what pumps are working and what pumps are not working every single day. But this was a big moment because it took us a long time to get there. And that's because inside that connected device is something like this. It's a lot of electronics, there's an integrated cellular modem, and we had to spend a long time, more than a year, developing this device to get it to a price point that made sense for this market, which was less than $50, and to optimize the power consumption so that it would last a long time on a battery. And it turns out that this is not a unique problem. So what we realized is, many of these you may recognize. Nest, the thermostat that goes in your home. John Deere has sensors out in the farm field measuring temperature or soil moisture, those types of things. The one on the left there is Eden, which is a soil moisture sensor for your garden. But what you might not know is that Nest actually spent $10 million and took a whole year to get that product to market. That wasn't the kind of money that we had available to build something for Thomas, and it's not the kind of money that most organizations have to build a new connected product. There are 16,000 new connected products estimated to come to market every year until the year 2020. I believe that's a Gartner estimate. And each of those has to make that huge upfront investment to get those products out there. And why is this? It's because hardware is painful. Number one, finding talent is painful. For every for every hardware engineer out there, electrical engineer, there are 30 software engineers, and people say that it's hard to find a good software engineering talent. Second, every time you have to redesign a product, you have to start from scratch, effectively. And you have to spend $100,000 to $500,000 on average and 6 to 9 months to realize a new iteration of your product. That's completely different than in software where you can roll something out in a day and get it out into the world. And finally, once those devices are actually out in the field, managing them is hard. You have to make sure that they're secure. You have to make sure that you're collecting information reliably, and then that data is going somewhere where it's actually useful. So our solution is IoT. And it's a hardware framework that we've been developing for the last 4 years, which is already deployed out in the field, and will be deployed on several thousand units by the end of the year. What IoT allows us to do, more than just being a hardware framework, is create a software tool that makes it easier for people to build these products. And what that looks like is, first you choose what you want to measure. That's as simple as saying, I want to measure temperature with these specific constraints. I want to measure voltage on a solar panel, for instance. Maybe I want to measure both in this particular device. And how do I want to collect that information? Do I want it to be 3G GSM? Do I want it to be LPWAN, LoRa, one of the up-and-coming new long-range radio frequencies? Or do I want it to be CDMA for Verizon? And it's as simple as selecting those options and then knowing what you want to measure. Second, you want to know how often do you want that information? Do you care about it every day? Do you care about it every week? Or do you have to have it within the hour as soon as something changes? So you define that in our software interface as well. Finally, you say, all right, now that I know what I want to measure and how often I want to measure it, how do I want it to be powered? How long do I need this to last in the field without any recharge? Do I want it to be also solar panel powered so that it recharges the battery automatically? And what do I want it to actually look like? So how do I integrate it into the standardized waterproof enclosure that we provide? Or how do I integrate it into a custom housing? And this is where the magic happens, because once we have those variables, because we have this standardized and modular interface, we can predict with great accuracy the cost of those units from 1 to 10 to 100 to 1,000, and not circumvent you needing to design any electronics, write any custom embedded firmware, or work with somebody like WellX directly to build your devices. And And then we can provide either a complete device for you, or work with, or give you a design that you can bring to somebody like WellX to manufacture that device at any scale. So then you can deploy your product, and without doing any electrical engineering, potentially, and any embedded software design, you can deploy your device at any volume and be able to be confident that it will be secure and robust when it's out in the field. If you do have something that's custom, that's very specific to the product that you're working on, it becomes a much simpler and bounded problem for the electrical engineer, the firmware engineer, to develop what they need for that particular customization and adapt it to this existing system, so you don't have to reinvent the wheel along the way. I went to UC Berkeley for undergrad, and go Bears. And I am fortunate enough to work with two of the smartest people I know, despite the fact that they both did their PhDs at Stanford. I'm also a former IBMer. My background is in software engineering, so I really understand the data side of this and the challenge that it is to extract data from the physical world and be able to control it again once you have that data. Andrew saw this problem firsthand as he was helping to build the hardware vertical at Starups, an accelerator at Stanford, and saw dozens of companies coming through and struggling with the hardware challenges that they needed to overcome before they could realize these incredible visions for what they could do with the data once it's in the cloud. We believe that not only is this possible, or does this enable the GEs of the world and the John Deeres of the world to create sustainable global infrastructure at the macro scale, but also that it can empower people like Thomas, that entrepreneur in sub-Saharan Africa, to build a hardware device that does what he needs without needing the background and expertise that is required today. Once again, we're Arch, and feel free to come and talk to me if you have any questions. Thank you very much.